Okay, so this is the fuel pump controller from the Jaguar hooked up to a pulse width modulation source that I can play with the pulse width. Carrier frequency is 100 Hz, and a little load in the form of a reversing light is hooked up just to show how the power is coming out of the fuel pump controller. I've got a bench power supply there. It's giving 5 volts to that microcontroller, which is switching 12 volts, which is what that needs. A little rotary pot there, which is giving an analog signal so I can adjust the pulse width. And this is the inside of this fuel pump controller, and it's more complicated than just a solid state relay. I think we've got a FET driver there, really chunky diode pack there, two diodes into one, and there is the actual power FET. It's got built-in temperature control in it as well. I've temporarily wired this up. I've got the proper plug for it using the pinouts that I've got there. It's got a pulse width modulation in, which is hooked into the 12 volt output of that, and a monitor port out, which is not hooked up to anything, but I have run that on the scope and it seems just to be some sort of pulse, fairly low frequency. The power out and the ground return, which switches to ground through the FET, goes into that little bulb holder. Like I said, it's 100 Hz carrier frequency, but it comes out at 20,000 Hz or something like that, so you won't see flickering on the bulb, or shouldn't do. At the moment it's switched down to a certain pulse width that this little microcontroller converts from the 100 Hz into the switching hit frequency of the actual power FET. So if we turn that up, you should see there's the bulb, and you can see we can change the brightness of that bulb by changing, this is the pulse width of the signal, and that then switches off. So you can just about see the mark on the pot there. So if that's the full swing, it's only about a third of it, a quarter of it, that translates to changing in the brightness of the bulb. Just got to figure out what that duty cycle is in terms of pulse width, but it may be between 40 and 60% duty cycle. The microcontroller turns into between 0 and 100% duty cycle on the actual bulb. So yeah, I've got a little bit of figuring out to do about what the actual concrete pulse width is, but that's running a couple of amps through a little light bulb. That seemed to be working, so I think I've got that figured out.